Hey everyone, it's Canfield. I'm going to run through the solving trig equations part 2, and I'll probably just do the left side of the page and leave the right side of the page to you. So on the left side, if we check it out, it says 2 cosine x minus 1 is equal to 0. So if you remember from last time, the big idea was we want this to just eventually say cosine x equals a number. And if we can get that, then we're pretty much home free. So the first thing we'll do, we'll add the 1 to both sides. So we'll say 2 cosine x is equal to 1, and then we'll divide both sides by 2, and we'll get cosine of x is equal to a half. After that, we're just trying to find somewhere on the unit circle that has a cosine of a half. And so if I go on the unit circle and I look around, remember cosine of a half means that the x coordinate is a half. And so if I'm looking around, oh, here's an x coordinate of a half. That happens at 60 degrees. So one of our answers is 60 degrees. The thing is, we want to find another place where the x coordinate is a half. So like over here, oh, that's negative a half, so it's not that. That one's also negative a half. Oh, over here. So 300 degrees. So you could have done, instead of saying 60 degrees, you could have said pi over 3. And instead of saying 300, you could have said 5 pi over 3. That's totally fine. Remember, I'm always going to take either one. So now, if I do need to do this one. So number 2, the thing about number 2 is when we get cosecant by itself by adding the 2 to both sides, we get cosecant of x is equal to 2. Well, remember that cosecant's the flip of something else. We don't actually have cosecant on the unit circle, but we do know that cosecant's the flip of sine. So if I flipped something and I got 2, what would I have flipped? Well, let's reverse flip it. So reverse flips back to a half. And so now we're trying to find, where do we get a sine of a half? Remember, sine's the y coordinate, and so that happens at these two. The y coordinate's a half at 30 degrees and 330 degrees. And so we're going to be able to use these principles through most of this. Something that we didn't talk a ton about in class yesterday was, or I'm saying yesterday because I'm filming this on an A day. Something that we didn't talk about last time was here. If I add 1 to both sides and then divide by 3, so we'll get 3 tangent squared x is equal to 1. Divide both sides by 3. So we're going to get tangent squared x is equal to a third. The thing is, when we take the square root of both sides to get tangent completely by itself, we have tangent of x. Remember, when we take the square root of both sides in an equation, we get plus or minus. And I'm going to remind you that this simplifies, the 1 over 3, it simplifies to the square root of 3 over 3. And so I want any place where when I get a sine divided by a cosine that I get a root 3 over 3. And if you remember from our notes last time, if you wrote these down, pardon me, we get root 3 over 3 when we wind up taking a half divided by root 3 over 2. Remember that tangent is sine divided by cosine. And so when we do a half divided by root 3 over 2, sine's a half, cosine's root 3 over 2. Okay, so let's see, sine is a half. So that's either this one or this one, right? Well, sine's the y coordinate, so that means that this one, sine is a half, cosine's root 3 over 2. That means that this is one of our answers, and so is this, because it can be positive or negative. So I get 30, I get 150, I get 210, and I get 330. So sometimes we can get 4 answers, which is kind of bonkers. Number 4 is very similar, so I'll leave that up to you guys. The only thing I want to mention is that the square root of 1/2 is equivalent to root 2 over 2. Sorry, I had to pause the video real quick. So yeah, square root of 1/2 is actually root 2 over 2. So if you ever have to take the square root of a half, you're going to, in these problems, you're going to want to get in plus or minus root 2 over 2. And that's going to wind up being a lot of different answers around the board. So Number 5, here's another interesting scenario. This involves factoring, but not the normal factoring that you might remember where we're trying to find something that adds and multiplies. This instead, we're able to factor this and say, hey, there's a sine and a sine. That's a sine squared and that's a sine. This means this actually means sine times sine minus sine. And so what we're able to do is we're able to say, well, hey, they both have a sine. Let me pull sine out. We're going to unmultiply them both by sine. We're going to undistribute that sine. And if I do that, I lose a sine here. I also lose a sine here. But remember that there needs to be something in its place. Otherwise, it won't show up when we redistribute it. So we got to put a 1 there. And so when we solve and factor, the idea is we're saying, hey, I got to set these both equal to 0. So sine of x, you need to equal 0. Oh, well, that's actually pretty findable. Let's see, sine is equal to 0 here. Our y-coordinate is 0 there, and our y-coordinate is also 0 here. So it looks like we got 0 and 180. And then we also got to take this other one and set that one equal to 0. So I'll have to solve this one and get sine of x is equal to 1. So when does sine of x equal 1? Y coordinate of 1. Oh, there we go. So at 90 degrees. Okay. All right, let's look at our next one. Next one gets back to the simple. We're going to subtract the 1 from both sides. We get 2 cosine x is equal to negative 1. Divide both sides by 2. We get cosine of x is equal to negative a half. And so I just want to find, hey, when does my cosine x? So when is cosine negative a half? When is my x coordinate negative a half? Looks like there and there. That's 120 and 240. Okay, this next one's kind of kooky. We're going to add the 2 to both sides. We get root 3 cosecant x is equal to 2. When we divide both sides by root 3, it says cosecant needs to be 2 over root 3. But remember, cosecant is the flip of something. Cosecant is the flip of sine. So it's really saying sine needs to be the flip of that. 2 over root 3. If we flip that, we get root 3 over 2. That's its reciprocal. And so now I'm just going and I'm looking on my unit circle. Also, if you recognize this handwriting, this is one of your unit circles. It's good. It's really good. I haven't found any errors with it so far. So 3 over 2 for the y coordinate. Okay, there's 1. And then there's the other. Okay, so 60 and 120. All right, so if you've made it this far and you're having any trouble, I would expect some trouble in number 3 and number 5. 3 and 5, I think, are pretty tricky out of the ones we've encountered so far. When we get to the back, there's going to be some trickiness, some not so much trickiness. I'm actually running short on time right now. This is going to have to be a really brief video. What I want you to do is I want you to do your very best. Try every single one that you can. Keep in mind that anytime we take the square root, it's going to make a plus or minus. I'll do at least one more of those before I go. I think this will actually cover a lot of things. So I think I'm going to do 11 and I'm going to do 13 just to help you guys out. So divide both sides by 2. I wish I had a couple more minutes, but there's some pressing stuff that I need to go take care of. I'm really sorry, but that's what you got to do. So sine squared of x is equal to a half. The way that we get rid of a squared is we take the square root. And I just want to remind you guys, the square root of 1/2, it simplifies to root 2 over 2. And I can prove that to you in class if anybody's interested. If you're like, I don't know why it's that, we can talk about it. But just please take my word for it. Square root of a half turns into root 2 over 2. It's one of those trick like formatting facts that we have. It's not, there's nothing else beyond that. But remember, we took the square root. And so this isn't the only answer. It could be positive. It also could be the negative version. And so because of that, I'm going to go and I'm going to try to find all my signs, all the y coordinates that are either positive root 2 over 2 or negative root 2 over 2. So like I've got 45. I've also got 135. And my negative root 2 over 2 down here, I've got the 225. And I've got 315. So 45, 135, 225, 315. Now the reason I don't like using degrees and the reason I prefer radians is these are all the pi over 4s. That's a lot easier for my brain to remember than all those different numbers. Okay. 13, I'm going to add the 4 to both sides. I get 3 secant squared x is equal to 4. Divide both sides by 3. We're going to do something a little bit weird here. When we take the square root of both sides, we're going to say, hey, secant, I can actually think about that. Instead of the square root of 4 over 3, I can think about this as the square root of 4 over the square root of 3. And hey, square root of 4 is a number, right? Square root of 4 is just 2. So I can say secant x, you're just 2 over the square root of 3. Oh, not quite. We took the square root, just like in the last problem, we took the square root. And so, yeah, positive 2 over root 3 is an answer. So is negative. So I write plus or minus here to remind myself it could be positive or negative. And secant was the flip of something. Secant was the flip of cosine. And so cosine of x is equal to plus or minus root 3 over 2. And I just want to go and I want to find all the x coordinates that have root 3 over 2. And I'm definitely rushing this just a little bit, or maybe a lot of it. But again, it's just because I gotta rush out of here. But I really wanted to take care of this before I left for the day, so you guys at least have something to go off of for class today. So for seniors who I'm not going to see next class, I hope that you're doing okay on this. Last one I'll look at before I go. See how this one's kind of already factored? It's got the tangent here. It's got the tangent of x minus 1. We can literally just say, hey, this one needs to equal 0. And so does this one. Oops. This was tangent x minus 1 needs to equal 0. And so all I've got to do is solve them independently. Well, I know tangent is sine divided by cosine is equal to 0. And so sine is y, right? So y divided by x. So 0 divided by 1, 1 divided by 0, 0 divided by negative 1, negative 1 divided by 0. 2 of these are 0. 2 of these are undefined. If you are not 100% sure which one's which, double checking your calculator. Not checking our calculator is kind of like a form of pride, and they say pride comes before the fall. Pride comes before we accidentally mix up which one's which. Sine divided by cosine needs to be 0. 0 cut into 1 equal pieces is in fact 0. 1 destroyed and cut up into 0 equal pieces does not make any sense. 0 divided by 1 is 0. And so 0 degrees is an answer. And 180 is the other answer. If you don't believe me, again, just double check in the calculator. All right, the very last one we'll do is number 17. 17 says sine of x times the sine of x minus 2. So since it's already factored, I can set them both equal to 0. The left one is pretty easy to solve. I'm looking for y coordinates that are 0. There's one, there's one. So I get 0 and 180. And here's the weird one. If I add the 2 to both sides, I get sine of x is equal to 2. And I go on the unit circle, and I'm trying to find a y coordinate that says 2. Let's see. No, 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 no. These are all negative. It's not going to be any of these. Guys, there is no y coordinate of 2 on the unit circle. This piece right here has no solution. Which just reminded me, I didn't actually finish the previous question. I did the left-hand side and then do the right-hand side. So let me do the right-hand side. I'm going to add 1 to both sides, get tangent of x is equal to 1. Now this is not plus or minus 1, so this is where I need to have them both have either both positives or both negatives. So that's our 45 degrees and our 225 degrees. Okay, so again, your job is to try all these, to be comfortable with everything on this and everything on the other paper. Next time I see you, if I don't see you on Friday for some reason, you need to know how to do this. And next week we'll be looking at the next topic. So hope this was helpful. If it wasn't, feel free to shoot me an email or send me a message on Schoology, or find me tomorrow on an 8-day. I would love to help. I want to help you guys finish the year strong. We're almost there. Cool. Thanks. Bye.